Okay, welcome to our first video. I'm going to begin the course by remembering how to find tangent lines. So I'd like to remind you of how to find the tangent line to a function f of x at some value x equals a. So here's the picture. I have the graph of some function f of x. I have a point A. I'd like to know the equation of the tangent line drawn in red here, the line tangent to the curve at that value. So here's what we could do. We can let y be our line. Now, some people like to write the line as mx plus b, but for us in this class, it's going to be more convenient to write lines in this form. a0 plus a1 x minus a. a0 and a1 are unknown constants, just like m and b are unknown constants. So these two forms of a line are the same, just written in a different way. If this is my line, then I could say two things about y. Property 0. I like to start my lists with 0, as any good computer scientist should. So 0. The 0th property is, if I plug in a to the line and I plug in a to the function, I should get the same value. All this is saying is that the graphs meet here at this point. The next property that a tangent line must satisfy is that the derivatives have to match. The slopes of the line and the function have to be the same at a. So that means their first derivatives are the same when I plug in a. I have two unknowns in the line, a0 and a1. I have two equations, equation 0 and equation 1. Equation 0 can help me find a0, and equation 1 can help me find a1. Let's do an example. Let's find the line tangent to the graph of, let's do e to the 2x at x equals 1. So here's the picture. We all know the graph of e to the x has exponential growth, very fast growth, shoots straight up almost. So here's the graph of e to the 2x. Here I am at x equals 1. So the tangent line might look something like this. Okay, let's solve the problem. My line, here's my answer. My line, in this case, y of x, looks like a0 plus a1 x minus 1. In this case, I'm taking a to be 1. Equation 0 says if I plug in a to this line, it should be the same as if I plug in a to this function. So plugging in 1 to the line, notice x equals 1 makes this term 0. Plugging in 1 gives me just a0. That's why this form of the line is so nice. That should be the same as if I plug in 1 to this function, so e to the 2. Okay, so I know my first coefficient. The second equation says the derivatives have to match. So the derivative of this line is just a1. That's the coefficient of x. So the derivative is a1. Constant term goes away. The derivative of my function, so over here I happen to know that the derivative of my function is 2e to the 2x using the chain rule. So if I plug in 1 to this function, it should be the same as plugging in 1 to the derivative. Plugging in 1 gives me 2e squared. So I know my line. I'm done. My line is y of x is a0 e squared plus a1 which is 2e squared, times x minus 1. All right, perfect.